Hey friends, happy Tuesday. How's everybody doing today? Hope you're having a good day. Sorry for the late start. We had a really cool workshop on doing these sort of flexible courses, continuing into the future. This idea that even when we're back to face-to-face being possible, trying to still do some sort of online synchronous or asynchronous option for the class at the same time. So that was a lot of fun. Oh, thanks. Someone popped in yesterday and they're like, "Oh, hey, you don't have an overlay?" I'm like, "No, I don't." And they're like, "Here, I'll send you one." So I was like, "Okay, cool." And then I spent, it took me all of 10 minutes to put it into Stream Elements, and now I can have chat showing. I was pretty excited there to have chat here, although it's a little squished, but that's okay. I'm not too concerned there. Yeah, so that was fun. And look, I even have my name here. How cool is that? Like, right over my picture? So, we'll see. I'm like a pro streamer now, right, Scholar? It's not some terrible looking... Oh, I got like all this empty space down here. I don't know what to do with all that empty space now. But that's okay. Let me know. I think the screen is still a decent size. So I think you should still be able to read everything, even though it's taking up a little bit less space in the overall view. But let me know. So we got a couple things, and then we are wrapping up this semester, which is crazy. So we're going to talk about design patterns today. That is one of our outcomes here. I think other than that, we've done pretty well. So we've talked about the Java application using modules being compiled and executed in a Java runtime environment. Right, when we start building out our classes and putting them in packages and things, and including other libraries, we've done that. We've talked about inheritance, composition, polymorphism, access specifiers, abstract classes, and interfaces. I think we've done that. Static class members are created and used. Also describe how they differ from instance fields. I don't actually know, we didn't use anything super static for the projects, but I think we've talked about static versus instance methods. Talked about exception handling, yes, with user-defined exceptions. We didn't do our own user-defined exceptions, but you just inherit from exception, and you can go from there. Basic input and output operations, buffered and non-buffered, including sequential and random file operations with text and binary content. We're doing binary content, right, with our final project for our save and load option. We're going to do some GUI components with multiple layouts and associated event handling. Okay, multiple scenes, using all the cool tools there. We should be good. Java annotations like @override. We're doing that. We've used @test, @fxml, some of those annotations we've been using. Documentation with UML class diagrams. We haven't done a great job at this. I've showed some UML, I believe. I just make them a Word. It's probably the easiest way to make them. Visio is like the right tool for it and all, but that's okay. And now we're going to talk about patterns, these design patterns like singletons, adapters, and factories. And then we're wrapping up all of the course outcomes here. And I think we picked up everything here then in the course description, which is actually really vague. This one's not super interesting. Cool. I've not gotten everything graded. I'm sorry. I'm working through it. All the midterms are in now. Still working through the backlog of projects. My little guy got sick over the weekend. I just can't catch a break, apparently. And if you get behind, it's just a big pile to dig out of. So I apologize for that. I'm working on getting him in been just working through it. So do let me know if you got questions or concerns. Your final project here. Again, your final project score can replace your worst scoring individual project. So if you're concerned about the individual projects, or like if you just did terrible on one of them, if you did great on the final project, you're fine. No big deal there. I do actually have, I need to grab this here. I have a survey for you fine folks to fill out. Need to grab it here. So the end of semester, we have a supplemental instruction survey to fill out. So even if you didn't attend any of the supplemental instruction sessions, please take a minute and fill out the survey here. So here's end of semester surveys. And if I add the link, it's stupid for whatever reason. It won't like open in a new tab correctly because this is supposed to autofill. So the SI survey, please fill out even if you did not attend any sessions. Okay, because it's like the URL right there, you see it's got some data points that should autofill, and for some reason it wasn't doing that with a direct link. So if you open in a new tab, it should be fine, I found out. So it's a quick little survey. Click that link there, and it should launch a new tab for you. And yep, course section name is autofill. Otherwise, you have to type it in yourself, and that's silly. Okay, so you can fill that one out for me. And then we also have, I need to go import this one, the end of semester course survey, which is evaluation and feedback for me and the course itself. I need to go import that for you. And this one is fully anonymous. I'll show you in just a minute what that looks like. Let's see, where's my downloads? D2L, there we go. And I just need to go change the date on it. Maybe. Come on, it's a small package. There we go. Review and manage dates. Oh, all right, forget that. Let's go to surveys. All right, and we'll make that available from today. What, 4/20/2021. We'll say 11 a.m. And then I do need this in by the end of class, so like 4/29/2021, 11:59 p.m. Okay, and you'll notice it is set to anonymous here. Right, so I don't get your information unless you type your own name in there. I'm not going to see it. So what I do see at the end of the semester, I go and I get to download all of these ones here. Let me go find. It's 21. Oh no, that's the wrong semester. Sorry. So like in the fall semester, I'll show you. Like this is one of the feedbacks I got from a 1500 section I taught. So I get to see, oh, only 7 people filled it out. Hoping to get more than 7 of you fine folks to fill this out. There's no names attached, but I do get all of your free text sections down here. Right, so it just shows up. Anything that you typed in shows up here. So unless you put your name in there, I'm not going to know who you are. Or if you put something very specific to like, hey, I had this circumstance happen that was very unique to me, you know, then I probably know who that was talking about. So again, just you know, please take advantage of doing this. These do go to my dean. I get reviewed as a new faculty member every semester for the first 3 years until they decide whether or not they want to keep me. It's not exactly tenure, but it's kind of like tenure. And then after that, they don't get reviewed quite as often, but they still go into the review packet that happens every 3 years and all that good stuff. So do take a minute to fill that one out as well. We put a link to that here in our end of semester survey. So add my survey. Should be the only one there. Yep. There we go. Please fill those out. Take a minute to do that for me, please. And we can go from there. Yeah, we got a couple more projects to work through here. I'll be getting those in as soon as I can for you folks. Other than that, we can move on to talk about design patterns. Design patterns are phenomenal. They're a common way of solving a problem, or you're using this pattern to solve a problem. So there's a book out and you can take a whole class on design patterns. There's this original group of folks who proposed some of these patterns and said, hey, these are some common ways we can use object-oriented programming to do things. And we've sort of taken on that and expanded upon it as we went. Kept on adding other ones, or kind of refining the process. So we're going to look at 3 of them that are important for now. And there's a whole bunch of them. You can take an entire class if you're going on for a bachelor's degree at a little higher level of all things design patterns you can do. We'll just look at a couple. The first one we're going to look at is what's called the Singleton Pattern. And the idea with a Singleton Pattern is that you want to have a single instance of something that exists. And then any bit of your code that needs to use that all goes and gets that single instance. So let me see here. I'm going to try and start up a new project here. Maybe if I get the right buttons. There we go. All right, we'll put this one in our 2151. And we'll call this, design patterns is fine. All right, and while that loads, again, just remember, this is going to be the last lecture. This is the last thing I have planned to demonstrate and to show you folks. Thursday I have set aside for working on the final project. Totally your time. If you want to meet, I can schedule individual meetings during that time, and next Tuesday as well. And then the goal on 4/29, again, if possible, we're going to try and meet up synchronously on a Zoom call where we can all take turns sharing screens, and you will present your blackjack game. And you can go through a quick play of it, show us how it works, show us your layout, your style, whatever it looks like, and we'll go from there. So that's sort of the goal. So we should be able to fit everyone into this 2 hours block here on 4/29. There's maybe 5 minutes a person, or team if you partnered up with anybody to show your game, and then we'll flip it over to the next person. You can show us for 5 minutes or less, right? I don't know how many hands you want to play, but that sort of thing, So to be ready to screen share, run your game, show us that presentation. Should be a lot of fun. You have 3 word bans, Scholar. You can save your points for next semester too. Ban something next time for me. Okay. So what I might want to do here, right? And again, this is just an example. This is not the only way of using this, but here's our design patterns. So maybe I wanted to add a new class here, and we'll call this our logger. Okay, so the idea with the logger is I want to share some logging among my application. I don't want every single class that I write, and again, there are built-in logging things, but this works out pretty nicely as a Singleton pattern, to share the same logging code. So not everyone has to figure out, hey, if I want to log something, I need to go figure out how to do it myself. I want to use a class that I wrote that will go and do it. So I'm going to have a private static print writer, probably a file writer actually, file writer, and I'll have a private static, yes, print writer, and yes, I need print writer, and these are going to start off as null, right? We're going to assign them null. So you don't assign static variables typically in a constructor, right? Because they're static. They belong to the class, not to a particular instance. Okay? But then what we're going to do is we're going to, when we create logger, right? If we call the constructor for logger, we're going to check, hey, if my print writer is null, it's going to go make one. If it's not null, there's nothing that has to happen there, right? So when we create an instance of logger, we go and just go do it here. We could probably even forget this. We'll just do public void log string message. We'll just do this. So when we go to log a message, right, we're going to say, hey, if print writer is null, we need to make a new print writer. So we'll make a new, so first we start with file writer. File writer equals a new file writer. I don't know, we'll just call it log.txt for now. Again, you could give it some sort of full path. You can make that configurable, that sort of thing. No big deal there. And we want to do all this in a try-catch block so we don't crash. Actually, you know what? Maybe we do want to crash. It's okay. We'll just catch it. This, yeah. Again, like you can get a logger out of this package here. That's fine. We don't need to do any of that. I don't know. We'll just print out the exception. Not ideal, but again, it's okay for now. So make the file writer. We'll hand that to print writer. We want to put this one into append mode, right? File writer. Now we hand that to print writer. So my print writer, the new print writer, given the file writer, and then append mode, is it? A for append mode or something? Why am I not remembering that? No. And a boolean. Oh, is it just true for append mode? I think it's true for append mode. We can Google it real quick, because I'm not remembering. Print writer, append mode. Probably one of the slides too, but print writer, yeah, true for append. Okay, that ought to do it here. Okay, so if it's null, create it, right? So we'll have a single instance of it here. And then we call our print writer. I guess we might as well, so whether or not we have created it or not, whether or not it's null, right? Now we can call my print writer dot print line the message. And now we're not going to close this at all. We want to leave it open that whole time because we don't want to have to open and close it every time we're using it here. Using the static version here. That should be static. Void log. So you don't need an instance of logger. This is a static method where we just have a single instance here. And kind of shared among all of them. I don't need that logging level. Okay. Or if I wanted to, I could give that print writer to someone else. I could return that print writer for use other places. So the logging method, you know, I could just expose the logging method here, or I could give them back that individual instance of print writer. Depends on how we want to do it. But what the idea here is that this becomes a single location, a single instance here that this class wraps around and make sure that, yes, we're going to use the print writer version for a singleton pattern. So any different class that I use can all access logger and use the log method or get its instance back out if I want to do something. Yeah. So back in our terrible kart racing game, right? If we were to actually build out the game itself, right? We probably only ever have a single track at a time. So track might have been okay to be a singleton, right? We could generate a track or have the single instance of track available to the game. We might want it to be a singleton where you don't want to have multiple tracks at the same time because that's really going to confuse our game. Right? You could have a single instance of the track. So you could use the singleton pattern where it's got a static one and we're always going to provide that same track every time. So there's lots of different ways to use that singleton pattern. So if you only ever want one, then we write this class that wraps around a single static instance of it. Okay, and then we all share it, which is pretty cool. So that's our logger. And then another really cool pattern is called the factory pattern. And the factory's job is to make instances. So, you know what? Let's, can we go back and do that? Maybe we can. Maybe we can go open up that project. That might be fun. That might be fun. So 2151, that was our project 3 was the kart racer, right? I think it was project 3. Or was that project 2? Yeah, project 3 was the kart racer. Right, so all of these were extending kart here, right? So they were types of kart. So we could create a class that will serve as a factory for karts. So let's do this. So let's make a new class. We'll call this the pcFactory. And the idea here with an pcFactory is that we have methods here to generate instances of those classes. So its job here is just to be a helper to generate versions of these other classes. So we might have a method public, let's have a motorcycle, get motorcycle, right? And it would create a new instance of motorcycle for the computer, right? Or whatever we're going to use if we want to put some other computer obstacles or computer players on the board here. So it's going to generate a new motorcycle. Motorcycle, if you could spell, motorcycle, motorcycle, the new motorcycle. And we have to give it some values here. So what track? Oh, well, we're going to need a track to put them on. All right, so we probably need to tell them a track here, right? So we'll give them a track. And then we've got what our speed. Where'd all those helpful hints go? Motorcycle. Max speed, acceleration, and brake speed. We could generate some random values, or we could just put a bunch in here. I don't know. Max speed 10, maybe brake speed's like 3, and acceleration's, I don't know, like 6. I don't know, let's make up some values. And then we could return that motorcycle. Okay, and then we might do this again for a get light cart, right, where we give it some values here. Light cart. There's a new light cart. We'll return the light cart, lowercase l. Right? Or maybe now we want to add in here, hey, let's do a harder mode. Maybe we want a more difficult, right, or a faster light cart, right? And we could change its speed over here, this sort of thing. So we make a class, and its entire job is to generate instances of other classes for us, right? Or maybe the factory itself needs it. No, we probably want to pass the track each time. I don't know if you want to pass the track into the factory. But all we're doing here is we're going to use this class to generate all my other instances. Its job is to just pump these things out. But imagine it's a factory. That's why we call it a factory, right? It will just go and create instances and hand them to me. So we can quickly get all sorts of different types out, or instances out from it. And what's cool, depending on how you've designed this thing, maybe we could have a bend factory that generates random bends every time. So that way, in some of your games you might have played, they're like procedurally generated, where they have certain patterns that generally fit, but they're randomly pieced together. So we could have some sort of factory code that says, oh, well, here's how let's procedurally generate something randomly in code, but I want it to fit a certain pattern. So we put all of those constraints, all that idea into our factory, and then we just say, hey, give me a new piece, give me a new chunk, give me a new chunk, right? The Valheim world is procedurally generated, right? There's some little random seed that it uses to make sure they're a little bit different, and then it just chunks pieces together of it. So you can use a factory pattern to say, okay, give me another piece here, give me another piece here, give me another piece here. So the factory pattern is really cool. You do a lot of good stuff with that one. Okay. And then the last one we're going to talk about is the adapter pattern. And adapter is really cool because its job is to make a bunch of things fit. Which I know sounds a little silly here, but let's see. I think I had a good example. Hold on, give me a second here. Let's see. Yeah, okay. So what we might want to do then, right? So the adapter pattern is all about making classes fit and talk to each other. Because trying to modify individual classes and make them comply or make them look like other classes doesn't always work as well. You don't always want to modify things. So let's see. So well, I don't want to do our bend there. No, let's add a new one here. So say we were going to have a class in here, and let's see. You guys are doing blackjack, right? We don't need to adapt any cards really. Trying to think of something that might be more interesting for you folks, but so I had it earlier and it's already out of my head. This is why some people write stuff down and use slides and things, but it's not usually my style. All right. Yeah, let's go this route. So we're going to build a register class here. Okay, and the idea with the register is we're just going to be tracking a couple values. We'll have a private double for total, and then we'll make a new register. And you probably want to give it a starting value, and it probably wants to track that as well, actually. So private double starting value, and we'll have a array list of type double for transactions. Okay. So we'll have this dot starting value is the starting value, and then this dot total equals the starting value. So we want to track the starting value, and then we're going to keep track of all of our transactions here. Public void add transaction given a double amount. Okay, we're going to take our total plus equals the amount, which could be positive or negative, which is fine, and then we're going to add it to our transaction log. Transactions dot add the total, or no, the amount. Okay. So all we want to do is we're going to just add transactions to our register, and we can go through it here. But now we might have another class, like I don't know, this is some, I don't know, taxable item, something like that. I think we've worked with one of these ideas before, maybe back in 1500, where you have, say, a private string for name. I don't know, name's boring, sure, and then a private double for cost, and then we probably have like a static, private static double tax rate. Right, and then we say that's like 1.06 or something for Michigan, our Michigan tax. And we put that public taxable item, given the name and the cost. Cost. Right, this name is the name. This cost is the cost. And then something like a double get total cost turns the cost times the tax rate. And then we also need, the get name. So we'll do some insert code real quick. Insert some getters. Name cost. So we can even get tax rate. Why not? Okay. So we can have these values here. So we can have taxable items. We can have non-taxable items. We can have all sorts of. What else do we want to have? This is. How about this is a rentable item? Sure, why not? So rentable item has a private double for total. I guess it's just rent, right? And a private string for name. Right, and then rentable item takes a string for name and a double for rent. This name is the name, and this rent is the rent. And then we might have, I don't know, we'll just add the sets and gets, right? Nope. Insert code, there we go. Sets and gets. So we can get the rent out, we can get the name out. Now, trying to log everything into the register, right, where all we really care about is the amount. Right? The idea of what we can do with adapter code is we can figure out how do we take one thing and make it fit into the other. So I don't really have a way of adding, I don't know if our array list wants items or not. That's okay. Right, I could in my code, right, it has a get rent, the taxable item has the get total cost. I might have a regular item that has a get cost as well, because they're not taxable. I might have lots of other ways of generating costs. Right, so what I could do is I could add a new adapter class. This is my register adapter, right? And its whole job is to take instances of one thing and make them fit into the other, right? So if I give it a rentable item, I can generate, hey, this is what you're going to do with the register. So let's take a private register, and then we'll make a register adapter that takes a register. I'll have this.register. So the idea is like I don't want to have to change the register class because I don't know who else is using it. But what I can do is I can build this kind of this wrapper around it to adapt it. So I'll have a public void add rentable item. It takes a rentable item, and I can take my register and I can add cost or add transaction for the cost of the rentable item. Get rent. Right, so like the adapter class knows how to do the translation from one thing to make it fit into the other. That way register doesn't need to change because I don't know who's using register. I don't have to add a bunch of methods to this base register to fit every other kind of class I'm ever going to use. Right, that's not really what register's job is to just, hey, I'm just keeping the list here. Right, so we're kind of following along with that idea that the class should do the things the class is supposed to do. And in our case, register just tracks the transactions, has my total. So I know how much cash is in the drawer. I've got my log, so I can check it later. Right? We can audit this thing after the fact. Right? But then the adapter's job, right, I'm kind of wrapping around it here, is that I can start, log rentable item or something? Maybe not add, so like log charge for rentable item. And a public void charge for taxable item. Taxable item. Given a taxable item, sure. And we'll take my register and we'll add transaction for the taxable item, dot get total cost. So the adapter's job is to know how to work with the individual classes. Right? And if we need to add more capabilities, we can update the adapter, but the register itself doesn't have to change. Right? So it kind of takes, like if you've ever traveled, right, we have plug adapters. Right? Our usual plugs don't fit into European outlets. You have to have an adapter that can make that thing work for you. Kind of the idea. So adapters are really cool. All right. That's a quick high-level overview. Again, you'll get more into design patterns and data structures. We cover a couple more of them there. And then again, you can take an entire class about design patterns later on. Just kind of want to tee off a little intro to them because you'll see them other places as well. Any thoughts, questions, concerns? How to handle aces in blackjack. Okay, so the rule of thumb there is what you're going to do is where do we want to put this? I'll just do it on the whiteboard. Try it on the whiteboard here. Whoa. Was one of my kids? One of my kids must have been using my whiteboard. That's weird. Okay. Anyway, so you have like your hand, right? And it has a value for total. Right? That's the total value of the hand. And it's either 2 up through any number, right? Relatively high that you can get to. I think the max is probably 30. No, 31. Probably 31, but that's fine. Like 31-ish. So if you have an ace and a 7, right? Your ace is either worth 1 or it's worth 11. So right now, you're going to assume it's an 11, and we're going to total it up. So we'll say our total is currently 18. Great. If we want to hit again, we get another card, and we say we get a 9. 18 plus 9, right now it puts my total at 27. 27 is greater than 21, so now I'm going to say, hey, my ace should only be worth 1 point. I don't want it to be worth 11 because I don't want to bust. So now my hand value is 17, so the value is either 21 or 17. So if you're over 21, you want the lower value. You want your ace to be worth 1. If you're under 21, assume that ace is worth 11. Does that make sense? So you might have like a total, you say like 4 card in cards, right? Total plus equals the card dot value or something. And then if card dot face equals ace, and total's greater than 21. Well, now let's take away 10, right? Minus equals 10. Count that ace as 1 if we went over. Cool. That's some terrible chicken scratch. I'm sorry. Right? How to make the game logic in the individual class. Like how to call the fxml controller for getting the elements. So the idea, right, we want all the game logic to be separate. We want to be able to do blackjack any way we want. It could be in a console application, it could be in a web application, it could be in a mobile application, it could be in our fxml application like we're doing it. Right? So like the blackjack game needs to track all the hands, it needs to have the dealer hand, it needs to have the deck, that sort of thing. We need to be able to have public methods that it can access. So in the controller then, we just say, hey, I want a new blackjack game. And then we can reference that from everywhere. So I think we've got some of our, where's one of our GUI projects? Let's take a peek here. So 2151, we were doing like graphics, right? When we were playing with some graphics. We'll open that up. So what we could do in the controller here then. So in our fxml controller, we could add another attribute here. So private, again, I don't have a game or anything. Well, just an array list of, type string for now. Values in values. Either I could add a constructor or in initialize. The initialize is essentially your constructor. But you can actually get at your XML things inside of, or fxml things inside of initialize. So I could say, hey, now values equals a new array list of type string. Great. And then when I click on buttons, I can add something to that here, right? Because it's just another class. I can take my values, I can call add, I don't know, some value here. So I can interact with that attribute that I have of my class. So this is the game, and the game should have public methods. Right, so when I click the button, hey, this is the hit button. I can call, hey, hit for this hand, or hit for anybody, or hit for the current hand, or whatever we want to do here. So we are connecting and using the methods here. So the controller is allowed to have more than just fxml stuff. But its job is to link fxml to the fxml page and have all the event handling. Does that help, Hudson? Cool. All right, other thoughts, questions, concerns? I mean, you can, it's just not going to work as well for you, because then we're going to be stuck and tied to only doing it in fxml. And I think, let me double check here, that some of your points here for using an object-oriented design, but I have been wrong before. So give me a second to make sure I put that in the rubric here. Yeah, so 5 of your points out of the 25 come from using classes for the game logic. Right, so like the game itself should be in its own classes. What the fxml controller does is call those public methods. So your class might have a hit. Your class might have stand as a public method. Right, or maybe you have a hand class that can hit or stand as methods, and then the game itself, can, hey, give me each hand. Because the game will have the list of hands for however many players are playing, right? Or again, because we're not doing split, we're not worrying about that. But like, game could have a list of players, and players could have a list of hands, which is usually one hand. But if you split, you get more than one hand. That's kind of how you could go about dealing with split. But we said don't worry about it. It's more complex than we need for get split. Right? I don't want this to be terrible. I want this to be fun. Ideally, it's fun. Maybe fun's a strong word there, but more interesting than doing nonsense projects. Oh my goodness, my screen is messing up here. Come on. That's all right. I'll have to fix that later. Yeah, so you get points for having your game logic separate there. 1. Okay. Okay, so your classes were just like, here's the data elements, but they didn't have any functions? Yeah, I would move them, because putting it all inside of the FXML controller is not essentially this. If it's going to be a ton of work, and like you're already done, let's chat with me and we'll see what we can do. I don't want to have to like rewrite everything, but I think it should port over pretty easily. This is kind of the thought, but we'll see. Okay, not done. Okay, so you probably can fix it then. Yeah, you want the logic to happen in the game classes. Okay, and again, take advantage of the partial points as well. Like focus one little feature at a time here is the way to go. And then as we move into this last week, if you do want to meet up, I've got the class time available to schedule individual appointments other than my regular office hours as well. And then I believe we still have study group sessions this week, but not next, was it? I'll check with our SI and make sure we're clear on when we have study group sessions. But get together with the study group and chat about, hey, how you might want to implement this, right? Talk about your design, about, all right, this is going to be my flow, this is what my classes might look like. That's definitely fantastic. Definitely worth chatting about with people. Okay. All right, well, that's all I've got for you folks today. So let's see where else we want to go. We can send a raid off somewhere for fun. We're so curious. See if anyone's even around. Yeah, you can go check out Boyd's Custom Fabrication. He does some cool stuff. He's a friend. Over that way. And we can go from there. All right, folks, it's been fun. Take care. Let me know if there's anything I can do to help. And if you get stuck on things, let me know. And it's been a lot of fun. You take care. I will see you for final project presentations, and please fill out those surveys. Thanks.